In our last video, we looked at figuring out what the LCD for these three fractions would be by using the ladder method or the birthday cake method. So I am going to click back and see what we found. We did our work and found that our LCD is 144. So now we can use that information to rename these fractions and then combine them by adding the tops. So my first step is to just rewrite those fractions as they are. This helps me keep a record of what's going on. When your brain is in the middle of a mix, it can be easy just to get lost. So the more notes you write yourself, the better off you are. So I am going to rewrite these fractions with 144 on the bottom because that is what we found the LCD will be. Now, we can't just magically say, okay, instead of a 9, I'm going to put a 144 here. We are following a math rule. And the rule we're following is that 1 times any number is that number. So like 1 times 5 is 5. 1 times 367 is 367. And 1 times 4/9 is still 4/9. Now we're using this rule in reverse from what we did before. Instead of pulling a 1 that looks like, for instance, 5 over 5 equals 1 because 5 divided by 5 is 1. So we did something like 5 over 5 times 367 is just 367. Now we're going to use this rule that any number over itself is 1, and 1 times a number is that number. And we're going to say that means we can go ahead and multiply a 1, and it will not change the value of the fraction. It will, however, make it look different. And that's what we want. We want it to look like a fraction that has 144. So if I know my goal is to turn this 9 into a 144, I need to know what times 9 equals 144. If my brain won't go there, another way to do that is to go ahead and divide 144 divided by 9, and that will give me the answer. So either by hand or with a basic calculator, we can do this. So 144 divided by 9. So my calculator just told me that when I divide 144 by 9, I get 16. That means that 16 times 9 is 144. So I'm going to multiply 4/9 by a 1 that looks like 16 over 16. So once I find the 16, 9 times 16 is 144. I then have to go up top and do 4 times 16. That gives me 64. 9 times 16 is 144. 4 times 16 is 64. 18 times what is 144? Again, we can do the same thing. 144 divided by 18. And we get 8. So to turn my 18 into 144, I multiply it by 8. I then have to multiply that top by 8 because this is a 1 that looks like 8 divided by 8. So 3 times 8 is 24. 18 times 8 is 144. I'm going to double check my work. 3 times 8 is 24. 18 times 8 is 144. The next one, 16 times what is 144? We find that by taking our 144 divided by 16. And we actually already know it because factors are like partners. So if I know that 16 times 9 is 144, and I know 104 divided by 9 is 16, that means 144 divided by 16 is 9. That's okay if you didn't get that. You can still go up here and do 144 divide 16, and you'll see that it gives you 9. So I then need to go and fix my color. I then need to go and multiply this 5/16 by 9 on the bottom to give me 144, 9 on the top, because 9 divided by 9 is just a 1, so I have to do it on top too. 9 times 5 is 45. Okay, so we have renamed our fractions so that the bottoms are all 144. We've got those tops that what they became in the process of renaming. So now I'm going to do my 64 plus 24 plus 45 all over 144. With multiplying and dividing, you reduce first and then you multiply across. With adding and subtracting, if you reduce before you add and subtract, you're really going to be going up here undoing the work you just did. So you're going to add and or subtract before you reduce. As simple as 64 plus 24 plus 45, 133 over 144. Now, we do need to see if this reduces. We have some quick checks. We know if they're both even, then we could pull a 2 out. The top one's not even. We know if they end in 0 or 5, they could be divided by 5. If they end in 0, they could be divided by 10. We don't know about the 3s. So the 3 trick is to add those digits. 3 plus 3 is 6 plus 1 is 7. If that was divisible by 3, then the number could be divided by 3. It cannot. So I'm starting to think that this one does not reduce. My next thing then is to go check my prime number chart. I know that 144 does reduce, and we have how it reduces back on our last page. So it reduces to 2 times 2 times 2 times 2 times 3 times 3. That only helps us if 133 reduces as well. So that's what I'm focusing on. And again, I'm going to check my prime number sheet and see what it says. Here is our larger prime number sheet. And if I look, it goes from 127, 131 to 137. So 133 can be broken down. It's not on this chart that tells me which numbers don't break down. So I do need to do some work here. So the strategy I'm going to use is to go back and look at what my 144 breaks down into. And I think it's like 4 2s and a couple of 3s. 1, 2, 3, 4, 1, 2. Yep. 4 2s and 2 3s. I'm going to write that down. So remember, when I reduce, I'm looking for like a number over itself like this, and that will be a 1. And because a 1 times anything is the thing, I can pull them out because they're not affecting the value. So unless 133 has 2s and 3s or 3's in it, nothing's going to cancel. So I don't necessarily have to break down this 133. I just have to ask myself, does it have 2's? Or does it have 3's? That's a little s. We already said 133 is not even, so there are no 2's in it. And we just checked 133 for the trick to divide by 3, and it has no 3's in it. So even though I didn't break down 133 to compare, I did enough to know that 133 over 144 does not reduce. That means that is my final answer.